Okay, so it's this week, uh, 10 for VS-360. In the second half of the class, what we're going to do is we're going to cover landfills. So just a few things to put in perspective. So I've got here this red. It's the waste inside of the landfill. Right here, I've got equipment like a truck, maybe bulldozer. Here, you've got your linings to maintain your lining by to ensure no leachate or soil vapor gets out. So you'll also have a leachate collection, leachate and soil gas, vapor or gas collection systems. You'll have leachate monitoring using groundwater monitoring wells. And you also might have some soil vapor monitoring in the area. So seeing all that in a little more detail, let's now watch somebody help us with this, help us understand this. Hope you can hear it.
Hi, my name is John Kawaguchi. We're here at the City of Glendale landfill. Behind me is
Let me just change that for myself because I'm having a hard time hearing.
part of the City of Glendale landfill's Hi, my name is John Kawaguchi. We're here at the City of Glendale landfill. Behind me is part of the City of Glendale landfill's gas collection system, 90 vertical wells and 9 horizontal wells. Vertical wells are 80 to 100 feet deep. Horizontal wells have laterals that lead to vaults. Vertical wells and horizontal wells are maintained to specific flow rates to provide maximum safety for gas migration. The gas management system has not always been part of the landfill. In 1993, a perimeter system was installed. In 2003, a second generation system was put in, and it included wells on the interior portion of the landfill, providing gas for the generation.
So as you can see, there's a gas collection that's taking place to convert the soil vapors into energy, into electricity.
Methane generation starts with the customer coming into the landfill and disposing of their organic material. As organic matter is brought into the landfill, it's anaerobically decomposes and produces methane. What I'm doing here is sampling the gas extraction well from the City of Glendale landfill. We monitor flow rate, temperature, and gas composition. Valves control the flow from each well. Methane, flow rate, temperature are monitored from each meter run. They're controlled to produce maximum gas migration off the landfill property. Regulation requires us to monitor and keep out hazardous materials from the landfill. I do an official spot check on loads that come into the landfill, and everybody's responsible for watching out for hazardous material.
Whoever invented this tool deserves a raise. I spent tens of thousands on.
There you go. You've got a little bit of information there. So now, let's say you're setting up your monitoring, right? Let's say you're setting up your monitoring of your landfill. What should you sample? What should you sample for? Now, for the groundwater, essentially what you're going to sample for is metals and inorganics. So this is the minimum that I would recommend. Volatile organic compounds to the groundwater to make sure that it's not nothing is escaping from the landfill and entering the groundwater aquifer. Petroleum hydrocarbons. Another thing that you can sample or test for. And polycyclic aromatic, right? Hopefully, you don't get any of that into your aquifer. Now, for soil vapor, what you would monitor for is methane, CH4. Double check that. And VOCs. Indeed. So I want to show you guys something or set up something that you guys do. Now, one of your assignments is related to landfills. Like, hopefully, this lecture will set you up nicely for that. We had a landfill nearby at the college. It's actually above ground, the waste. It was buried above ground. A lot of the waste. First remember that, right? However, but it's an old landfill. They didn't really do a great job covering it underneath. And so their thought was that they could actually have soil vapors heading in different directions. So guess what they did? They built soil vapor vents. With screens. And they look like lampposts at a park. So they did this every 50 or so meters. We used to have access to this site. We don't anymore. And we have another set, another 50 meters. And then in between, there'd be monitoring points. There'd be monitoring wells. For soil vapors. And I remember that initially you get 250 to 500 BPM. And then by the time you get, it would basically go down almost exponentially as you got further away from the site. So that would be the VOC levels, and that would be distance. Yeah. We did some of the monitoring back in the day, all the way to where it was like less than 5 ppm near residential or institutional buildings, which is not really concerning. I think you get more than 5 ppm just with our body odor or our clothes. So let's now go through some slides to help us understand the topic a little bit better. Hmm. Okay, let's look. This is what a landfill site looks like. See all the trash, equipment. I would recommend having this type of PPE. This looks more in line with what I would recommend. It's brought to the site in a truck or in a hauler. Yeah, here you go. You've got your PPE set up. And you can move the material around with a bulldozer, front end loader. And what modern landfills are designed to not only accept waste too, but not to allow for environmental issues. They they try to minimize infiltration. They try to place a daily cover, which is soil. So what problems do landfills pose? Well, you could have groundwater contamination. You also have landfill gas. You could have subsurface landfill fires. You could be generating offensive odors. Litter could be an issue. You might have pests, vermins, seagulls. So if let's say there's a residential area nearby, they would definitely have a problem with this. You might have issues with traffic. Long-term settlement might be a concern after completion. Let's stop the share. Let me start that again. Seem to have lost myself there. I got the oud going. That's why you might see some. It creates a nice scent in the home office here. That's why you might see some. Okay. Okay. So hopefully you can see the slides. And groundwater contamination can also occur. And that's why leachate that's formed in the waste, especially when water percolates through it, it can become an issue and it's highly toxic. Look at all the chemicals that I discussed that you want to make sure that you collect. Landfill gas is also produced and it can change over time, the composition of landfill gas. But usually it consists of, well, I said it was methane and VOCs, but it also has carbon monoxide, carbon dioxide. You can also have fires that are created inside of the landfill, and they can be extremely difficult to extinguish. I mean, they could be burning for a very, very long time. So in terms of the design, here are some of the concerns that you look at, right? You would have an environmental assessment. So what you would be looking at to before you install such a structure, a landfill, which actually I don't think they're approving them these days, from what I understand in Ontario. They're they're very reluctant to approve these type of facilities. But you want when if you are working on any such project where you're proposing or you want to create a new landfill, location is important. Having a liner in place when you're designing it, compacting the waste, having a daily cover, making sure that you understand what needs to be done to cap the landfill, having a leachate management system that collects it, and also a gas management system. So this is what a typical landfill would look like. And this is what I was trying to point out to you guys earlier. Let's see if I can. I have the ability to write on. Let's see if we can. There you go. So here's the monitoring well that I was referring to right here. Here is the leachate gas collection system. And this system here, it actually creates electricity from the gas by burning it. Here's your clay liner. That's shown here. Here's the actual trash. And you can see the leachate collection system. It pulls it up, it's pumped out and sent this way. And here you can collect your gas, your leachate gas. Now, these slides only refer to carbon dioxide and methane, but include I would also include VOCs as well. Solvent. Go to the next slide. So in order to get permitting for such a structure, no matter where you are in the world, you want to select a geologically stable area. It's not located on top of a major aquifer. It's not located in a vulnerable area. It's designed to reduce the risk of damage to the environment, and it should be monitored before and after when you close it. Let me now talk to you guys about an interesting case study that I was a part of years ago. I was in a group that tasked with tasked with approving a landfill. Well, they did a groundwater study, and so this well in the middle, it had an elevation for the groundwater 110. And then we had one here that was it was 116, 20, 140, 150. There we go. Approximate amounts. 40, 112. Essentially, what I want to show you guys here is that the 115 contour for the groundwater looks like this. The 120 contour is like this. And then the 140 meters above sea level contour is like this. Okay, sorry, I lost you there for a second. So this is 150 con, 140, 120. 115. So which way is the groundwater flowing? We just did flow nets. So what is the structure like? It is likely a sinkhole into a aquifer. Into an aquifer. Therefore, I had recommended that not through this lab, because if there's any leachate that gets out, you're likely going to have a catastrophe in terms of the groundwater. Continue now. You want to go and drill at the site, collect some soil samples, see what the geology is like. And then based on an understanding of what the aquifer is, what the depth is, what the groundwater is like in terms of the flow direction, like we just assessed back here. You also don't want to create a pathway so that we would have a huge contaminant issue down the road. Now, in terms of the liners, once you've started to construct your landfill, you can have compacted clay, bentonite enhanced sand. Bentonite's like clay itself. It's a form of clay. You can also have textile or geomembrane. You can have concrete, but usually you want to have a combination of all of the above. You can see here, you've got the construction taking place at the bottom, and you're putting in the liners, and then you've got your leachate and soil gas collection systems. Here's what the installation of a geomembrane liner looks like. Now, this is where you've got the workers are installing their asphalt liner. This is quite popular in places like the UK. This is what the landfill looks like when it's ready to be installed. You've got your greater cells here, and then these will be split up into smaller cells. So it needs to be, contractor needs to be supervised by an independent consultant. And it needs to be certified at the end. So waste should be placed approximately in 3-meter thick layers. And at the end of each working day, you should place 0.3 meters of clay or sand material on top to minimize infiltration. Infiltration into the subsurface aquifer, and to isolate from birds and vermin and reduce odors. And you want to also prevent having a situation where material you could be scraped away at, or if you could have leachate that collects at the base and recirculates, that helps with the decomposition. You don't want this leachate to be wasted. And then what you do is at the end is you install compaction on top, and then another membrane when you finish it. So you've got your cell here, you've got your cap on the top, and you've got your collection systems for the vapor. So leachate managed systems are basically meant to prevent accumulation of leachate, to collect and recirculate and dispose of the leachate, They're usually a drainage blanket at the base, and you also have pipes along the base and sidewalls of the landfill. And you've got wells to monitor and extract the leachate. Leachate gas management systems are also installed to prevent gas from getting into the subsurface, and they can be managed passively or actively. So what do we mean by passive? It means that it's just perforated pipes and the gas is allowed to vent, just like that case study I was showing you earlier of that old landfill. Active systems are where you're actually pumping the landfill gas into these unit that creates the electricity. Got the pumping, the gas. Here you can also see that they're installing something here. I think it's the installation of the cheat in the landfill gas management system. Here in this image here, you've got the electricity being generated by the landfill gas. So like I said earlier, monitoring needs to be put in place upstream and downstream to check for contamination and to regularly check to make sure that there's no groundwater being contaminated or leachate or landfill gas escaping. So yes, they are not the most pleasant places to be around, but if carefully designed and constructed the right way, you can have a pretty good system to manage the landfill material that's brought onto the site. Okay, now let's watch an expert talk about this topic. It's a pretty good, it's quite well done, this video here. So let's watch this. It's about 7 minutes long.
Hi, it's Mr. Anderson, and this is AP Environmental Sciences, video 31. It's on solid waste. Generally, in the natural world, waste is not wasted. These two dung beetles are fighting over this ball of elephant dung as a food resource, and through most of humans' history, we really haven't produced that much solid waste. This changed post-industrialization, especially after World War II. We started to live in a throwaway society, where we produce waste that we don't reuse, recycle, or fix when it's broken. And so we're filling up landfills with waste that the natural world doesn't want. These seagulls might eat some of the food, but the rest of it will lay in this landfill for thousands of years into the future. And so MSW, or municipal solid waste, you should understand what are the major types of waste. It's generally going to be paper, plastics, wood, yard clipping, metal, things like that. There are a couple of types that you should be familiar with. E-waste, that's going to be our computers, phones, and televisions as we throw those away. And then hazardous waste. This is going to be waste that causes an impact in human illness or changes that degrade the environment. And we have regulations in place. The two ones you should be familiar with are RCRA, the Resource Conservation and Recovery Act, and then CERCLA, otherwise known as Superfund Act. And that's a way to...
So that's in the United States. Here, it would be under the Environmental Protection Act and the regulations that I mentioned earlier in the class.
Clean up huge areas of hazardous waste. That solid waste is eventually disposed of either in a landfill or incinerated, but the key point is, how do we reduce the amount of solid waste? How do we minimize that? The one you're probably familiar with is the idea of the 3 R's. We should reduce it, reuse it, recycle it, and a type of that is going to be composting. And so municipal solid waste, if we look over the last half century in the US, it's been increasing from 88 million tons of MSW in 1960 to around 251 today. So you can see it's increasing over time, and it's starting to level off as we start to recycle more of that. And this is per capita, per person, how much waste we're producing. You should be familiar with what most of that waste is. This is from the EPA. It's generally going to be paper, food, yard trimmings, plastics, rubber, metals. 251 million tons per year. If we look at how much is actually disposed of, it's around 65% of that. This is to scale. And the reason why is that we're recycling a lot of it. We're recycling especially the paper, the yard trimmings, and the metal, composting a lot of those yard trimmings. E-waste is a type of this waste. It's going to be the electronics. We put some of this in landfills. Unfortunately, a lot of it moves to developing countries where they recycle the parts of it. And there aren't standards, health standards in place, so it's really dangerous. And then we have hazardous waste. So chemicals that have been produced, oven cleaner, for example, in your house would be an example of a hazardous waste. And so we don't just bury that because it gets into the ground supply. And so we've got regulations that make sure that we're storing it properly. And that legislation could be broken down into RCRA and CERCLA. RCRA is going to be the Resource Conservation and Recovery Act, and then the Superfund Act. If we look at RCRA, that's going to regulate hazardous materials from cradle to grave, from the point it's created to when it's eventually stored. The way that works is we leverage taxes on the industries that produce these hazardous waste.
An example is the environmental tax that you would get on, for example, tires, electronics. If you go and buy a TV or computer, you'll get that tax on the front end.
And we can use that to help store them. And so, for example, that oven cleaner in your house that you bought for $5 is hazardous waste. And so when you're done with it, if you don't use it, it's going to go to a place in your city where they can control that as a hazardous waste. The Superfund Act started with a very famous contamination. It's called Love Canal. This is in Niagara Falls, New York. And so back in the 40s and 50s, a chemical company had been dumping hazardous waste and simply covering it. And that eventually that land was sold off to a school, houses were built on top of it. We started to get birth defects, miscarriages, huge increases in illness, and they finally could trace it back to this. And so what the Superfund Act does is look at areas where we have huge contamination due to hazardous waste. All the red ones on here are Superfund sites. The green ones are ones that are done, and the yellow ones are proposed Superfund sites. And so what we're doing is cleaning up the hazard waste and holding those responsible, if they're still around, those people who caused the contamination. And so how do we minimize the amount of waste? We don't want to dispose of it, and so we can think of it like this, from the least favored to the most favored. So we can dispose of it, or we can get some of the energy from it, but we want to recycle it if we can. We want to then reuse it if we can, and reduce it in the first place. So if we kind of break through those top three in recycling, as this material goes to the landfill, we have people that can remove some of that recycling stuff that we can use again. Now that's pretty energy intensive, and so if we can have us do the sorting before it actually gets there, that's helpful. We have what's called closed loop recycling. That's where we take something like aluminum cans and we recycle that back to make more aluminum cans. And then we have open loop recycling, and that's when we take something like plastic bottles and we can use that to make more plastic bottles.
So we're going to talk a little bit more about that in the coming weeks, after you're done with your phase 1 ESA.
Or we can use it to make something like a polar fleece jacket. We also want to recycle nutrients. So composting in your backyard is a way to reduce the amount that goes to the landfill, and even at a large industrial scale. What we want to do is take those nutrients and put them back into the environment. We can reuse things. So this is a giant coil we had electrical coil that was wrapped around it, and it's now used as a table. So if we can use things again, if you can give it to somebody else, give it to Goodwill, you can sell it through eBay or Craigslist, then we can
So if nothing else, one of the good lessons of this course that I hope you take away with is try to reuse stuff. Go ahead and buy stuff that's used if it's not something that that would disgust you if you were to wear it and use it. Other stuff like tables and so on. And if you don't want to use something, give it away so that people can use it, or let other people sell it for you, like Value Village.
reuse this material, and at the best we want to not even make it to begin with. And so if you have a bag that you take to the supermarket, then you don't have to choose, do I want plastic or do I want paper? You're not using either of those, and we can do it on an industrial level as well. So Subaru, for example, is one of the first companies to go to a zero landfill policy. They're not putting anything in landfills. How do they do that? They're recycling, they're reusing materials, and the little bit that's actually produced at the end, they're incinerating that to produce energy. And so this is what one of these plants looks like. We can burn that garbage or that unused garbage to produce a little bit of energy instead of not using it at all. And so if it eventually moves to the point where we have to dispose of it, we have to make a landfill properly. How do you do that? You dig a big hole, and then we're going to line it with plastic, or better yet, clay. Clay is not going to allow material to leach out, and then it's also going to grab a lot of those metals just due to its charge. We then put a leachate system in it, so it's a bunch of pipes, and so any water that leaks out is going to be recovered. Sometimes it's recycled back again. We then fill it up with garbage, and then we're going to cover it with soil. We want to make sure that we compact it the whole way so we don't have a lot of decomposition going on in there. We don't want a lot of water to move down there. We'll also build pipes in there because methane gas is going to be produced, and we want to get rid of that as well. And so did you learn the following? Do you know what solid waste is? The worst type is going to be hazardous waste. We've got RCRA on the Superfund Act to kind of regulate that. We want to minimize it. We can reduce it. We can reuse it, recycle it, and compost it. And then if we have to, we can incinerate it. That's called waste to energy system. And then a last kind of ditch effort is to put it in a landfill, but we want to make sure that we construct it properly. So that's solid waste, and I hope that was helpful.
I also hope that that was helpful to you guys. So what I'm going to do next is round off our class with one more item. A few years back, we were called by a client to investigate an illegal dump. Back in the 2000s. So they had a homestead trying to develop that. This homestead had been leased to these people as a farm. Right? But they had no record. So you've got crops. Farm. There's a barn in the background. We'll just put it back here. Barn. There's no record of them ever, no receipts of, because in this part of Bolton, you have to pay the city to come pick up your trash, or you have to take it to the dump. So we were investigated. We looked across the site. And we found disturbed areas. Then we started digging. And lo and behold, a bunch of trash at different spots. So the owners of the house said, not our trash. It's what we basically, oh, my camera's not working here. So we basically so I'll set this up for you. What we ended up doing is we dug up and went through, we audited the trash. And what we did is we found the name of the renters on items in the trash. So what they had been doing was they had created an illegal dump. And we should the report. and the client is able to get them to pay for the cleanup of the illegal dump. So that is that for your classes this week. Spend the rest of the time this week that's left in the class going through the legislation that I've posted, 102, 103, and 347. Shouldn't take you more than half an hour. And then continue with your work on your phase 1 essay. All right. So have a great rest of the week. And I will give you instructions for next week later. All right. Enjoy yourselves.